Hello everyone, welcome to my channel Physics Sticks. So let's start with NEET 2021 solutions. In this I'm taking 10 questions and this is the part 1 of the solution. So see here, this is the first question. An infinitely long straight conductor carries a current of 5 ampere as shown. An electron is moving with a speed of 10 to the power of 5 meter per second parallel to the conductor. The perpendicular distance between the electron and the conductor is 20 centimeter given. At an instant, calculate the magnitude of magnetic force experienced by the electron. So we know that this is a very simple question, and the magnetic force formula we know that, and that is Q into V into V into sine theta is there, but here the velocity in this direction and magnetic field is out of the plane, so that's why the angle between the magnetic field and the velocity is 90 degree. So you can write sine 90 as 1. So Q is given, that is charge on electron 1.6 into 10 to the power minus 19 into V is given 10 to the power 5 into the magnetic field due to this long current carrying conductor is mu naught I divided by 2 pi into dV. How? So just put the values and you will get 8 into 10 to the power minus 20 Newton as the answer. So first question answer is 4th, right? So next one, in this second question, a dipole is placed in an electric field as shown in the figure. In which direction will it move? So this is the dipole given, that is Q and minus Q. So in which direction this dipole will move, that is what we have to calculate over here. This is the charge, and as you can see from this diagram, we can conclude that this charge is a what is called as the positive charge, as the electric field is moving out of this charge. Okay, no problem. So on this charge Q, the electric field force due to this electric field will be in this direction. Why? Because this is positive repulsion, this is negative, so this force will be in the attractive force and in towards the positive charge. Now as you can see, E1 is lesser than E2. Why? Because as the distance increases, the electric field decreases. Okay, so E1 is less than E2 indicates the force on this charge, that is F2, is greater than on this charge F1. So this dipole will move towards right. This dipole will move towards right, and we know that system always tries to minimize its energy, right? It always tries to maintain its maintain at its minimum energy. So towards the right, and as its and potential energy will, what will happen? Decreases, right? Now unless and until external force we provide, the system energy will not increase. Okay, so this is the second question. Third question, an inductor of inductance L, a capacitor of capacitance C, and the resistor of resistance capital R are connected in a series as shown in the figure. Potential difference across L, C, R are given. We want what is called as the impedance. So impedance formula we know that is Vrms by Irms. Here it is given peak current 10 root 2. So peak current divided by root 2 will give you the RMS value of current. So I naught divided by root 2, that is what I wrote over here, 10 root 2 divided by root 2, and root of Vrms we have is root of the Vr squared plus V inductor minus V capacitor, or V capacitor minus V inductor. That is totally your choice, because square of that term will be the same thing. So root of 2500 divided by 10, 50 by 10. So answer for this question is 4th. So I hope this is clear. So this is the third question. Now fourth question, for a plane electromagnetic wave propagating in the x direction, which one of the following combination gives the correct possible direction of electric and magnetic field? Okay, so see here, electric and magnetic field, we know that electric and magnetic field are always perpendicular to each other for electromagnetic wave. That indicates the dot product of these two must be 0. If it is electric field, if you consider, and this is if it is magnetic field, if you consider, they must be 0, right? Dot product must be 0. So if you consider dot product of this, you will get 2. Dot product of this 0. This one we have is -1, -2. This one we have 2. Indicates only one possible option over here, and that is option 2. So fourth one, option 2 is the correct option. Then we have fifth one, a lens of large focal length and large aperture best suited as an objective of an astronomical telescope, since a large aperture contributes to quality and visibility of image. Yes, it is true, right? Why? Because whenever large aperture is there, energy incident on that aperture will be the more, and it will give the more visibility of the images. A large area of objective ensures light gathering power, right? So we have yes, if we have the large aperture area, then light gathering power will be the more, right? Better light gathering power. Yes, it is correct. So first and second correct indicates the fourth one correct. A large aperture area provides better resolution. Resolution formula, if you don't know, first and second correct. That's why fourth also correct. Very good. So that is all of the above. Now sixth one, column 1 and column 2 gives this one, and we want what is called as the what are the best possible options. Drift velocity, as you can see over here, acceleration into relaxation time is the drift velocity. Initially we'll consider the initial velocity as 0. So acceleration is small e capital E divided by m into tau. So small e capital E divided by m into tau. So this every teacher will give this formula initially while starting the what is called as the current electricity, isn't it? So this is the R we have. First one R we have, then electrical resistivity R A by L, most of you know. So R is V by I into A by L. Now V by L is E and I by A is J. So E by J is rho. So B1 S is the correct answer. Relaxation period, as you can see, VD is I by NEA, and this I by NEA is small e capital E by M into tau. If you just rearrange this, you will get M divided by NE square rho, that is P. And current density is we have I is equal to NEA VD, so I by A is NE VD, so that is Q. So RSPQ, and as you can see RSPQ, this is given in option 1. So I hope this is clear. Now the next question. In this question it is given an electromagnetic wave of wavelength lambda is incident on a photosensitive surface of negligible work function if m mass of a photoelectron emitted from the surface has a de Broglie wavelength lambda d. Then de Broglie wavelength indicates what? The momentum we have is h by lambda d right now, h by lambda d. So kinetic energy we have hc by lambda, which is p square by 2m, and this p we can write h by lambda d, that is de Broglie wavelength we can write. So if you just rearrange this, you will get lambda d square as lambda h divided by 2mc. Lambda d square is equal to h by 2mc into lambda, and we have lambda d square into 2mc by h is equal to lambda, and as you can see, this is given in option 3. So next question number 8. A particle is released from height s from the surface of Earth. At a certain height, its kinetic energy is 3 times its potential energy. We know that whatever potential energy is over here will be whatever total energy over here will be the total energy at this point also. So total energy, if you just equate mgs plus kinetic energy 0 is equal to the kinetic energy at this point, if you consider kinetic energy Ke plus the kinetic energy Ke, right, potential energy as Ke by 3, or else kinetic energy plus potential energy, right? Kinetic energy has 3 times potential energy, it will become 4 times potential energy. So potential energy is this is mgs, which is equal to 4 times mg h dash, supposed to be height. mg get cancelled, and h dash we have is s divided by 4, as you can see over here. So s by 4, so it is given in 1, 2 and 4. So third option not at all possible. Now we'll check for the what is called as the velocity. Half mv square is equal to 3 times mg h dash. Just now we have calculated s by 4. Put it over here and you will get 3 by 2 gs, and that is given in option 4. So I hope this is clear. This is the 8th question. Now 9th question. A screw gauge gives the following reading when used in the to measure the what is called as diameter, right? So whenever the full reading, if you want, reading is equal to, always remember this formula, and that is main scale reading plus the circular scale reading, least count into circular scale divisions, we can say, right? So which is equal to, what is the main scale reading over here? 0 plus least count over here is 1 millimeter divided by 100, that is 0.01, into what is the circular scale division? It is given 52. So matching circular scale division actually, and that is, if you just calculate 0.52 millimeter, or we can write 0.052 centimeter. So it's very simple if you go with the basics, right? So I hope this is clear. So this is 4th option, which is correct answer, right? Okay, so 10th one. Now as you can see, this is also very simple. It will be like direct formula based. A thick current carrying cable of radius capital R carries a current I uniformly distributed across its cross section. The variation of magnetic field due to the cable with the distance R from the given figure will be. Okay, so see here, it is given which carries a current I uniformly over its area. So we know that inside the conductor it is directly proportional to R and outside it is inversely proportional to R. So if you just draw the diagram, you will get somewhat like this graph. So this graph is valid for gravitation also, right? Only difference is that the gravitation you will have is negative side. If magnitude wise, if you see, this graph is for magnetic field versus the distance, or gravitational field versus the distance. Okay, so I hope this is clear. So answer for this is yes, it is third one. So part 2 of this will be, I'll upload this within like 1 hour or something. Do watch this video, do subscribe to my channel. Thank you so much.